Good morning, myself Dr. Pawan Bhambu. Today's topic Von-Neumann architecture as well as fundamental of computers, in which we will be going through the fundamentals of computer, its hardware and the process, how the computer works. First of all is Von-Neumann architecture. We can see how the computer block diagram is in front of you, how the computer works there and how it is having different integrated units. There are input unit, a CPU, a central processing unit and an output unit. That you can say this is the sequence how the work is done by the computer. Input, we will be talking about the input devices. We are very familiar with them, keyboard, mouse and all. And the central processing unit is responsible of carrying out all of the operations, the mathematical operations from the memory and then back displaying the result using the help of control unit by passing control signals, commands and all to perform a particular task, and then outputting the result to the output unit, the devices that are monitor, projector and all. How this happens we will see in detail. Next is input devices. In picture we have seen there are a lot of input devices: keyboard, printer, mouse and scanner, camera and all. These are all input devices that are used to give input to the processing unit, central processing unit. Then the CPU. This is entirely a theoretical part. We have to understand it and we have to revise it number of times so as to remember to write it in our exam for getting good marks. Okay, the central processing unit, the CPU, this is the unit that is responsible for carrying out different mathematical operations and different operations for input and output, receiving the data and giving the data to the output unit. It is having ALU, arithmetic logic unit, and the control unit. The arithmetic logic unit is used to perform all of the mathematical operations, Boolean, logical calculations and all. And the control unit, control processing of what instructions, controls movement of data with the CPU. From the CPU to the memory, from the memory to the CPU to the output device and from the input device also. How this is carried out we can see in the figure: the CPU, the ALU units, the cache, the DRAM and the CPU. Next is the memory. What is the memory? The next part in the CPU. We have studied about the input unit, then we are on the CPU unit, the central processing unit. In CPU we are studying about the memory. What is memory? A memory is a physical device capable of storing information temporarily as well as permanently. If temporarily, it is a primary memory. If permanently, it is a secondary memory. Memory is of two types: primary memory and secondary memory. Primary memory is a volatile memory and example is RAM, okay, and in some of the cases ROM also. Secondary memory is the permanent storage memory and it lasts data for longer time. We can use it for long time storing of the data and information also. In pictorial representation we can see the memory is divided into primary and secondary memory. Primary memory is again divided into RAM and ROM. ROM is of three types: PROM, EPROM and EEPROM, and RAM is of two types: SRAM, static RAM and dynamic RAM. Again the secondary memory is divided into hard disk, floppy disk drive, DVD drive and pen drive. It is very clear. Next, primary memory. The types of primary memory, which is a volatile memory, means the data is temporarily stored until the power is on. After the power is off, the data is volatile. Example, RAM. After switching off the computer, the data which is in RAM that is deleted. After restarting the computer, we are not getting the data back, and it is accessed directly by the central processing unit. The types of primary memory: RAM and ROM, RAM, SRAM and DRAM, ROM, PROM, EPROM and EEPROM. from. We will be seeing it. What are they? Random access memory, which is a volatile. Read only memory, that is a non volatile memory. What are the differences and what are their working, we will see further in detail. Random access memory, it is also called a read write memory or the main memory or the primary memory. The second point, the program and the data that the CPU requires during execution of a program are stored in this memory. It is a volatile memory as the data losses when the power is turned off. RAM is further classified in two types, static RAM and a dynamic RAM. Next is ROM, read-only memory, stores crucial information essential to operate the system like the program essential to boot the computer, means how the computer will be starting in initial phases, that is how the computer will be booting, that is the boot program is written in this ROM by the manufacturer when the system is manufactured. It is not a volatile memory, always retains the data used in embedded system or where the programming needs to change, used in calculators and peripheral devices. ROM is further classified into four types: ROM, PROM, EPROM and EEPROM. ROM is simply a ROM, that is only read only memory. PROM is a one time programmable ROM. EPROM is one or two time erasable and again programmable ROM, and EEPROM is electronically erasable programmable. It can be programmed again also. Types of ROM we can see. I have discussed in advance also. PROM, programmable read-only memory. It can be programmed by user. Once programmed, the data and instruction in it cannot be changed, only once. EEPROM, erasable programmable read-only memory. It can be reprogrammed to erase data from it, expose it to ultraviolet light, to program it, erase all the previous data. The process can be done for 1 to 2 times only by deleting the data and reprogramming it. Then electrically erasable programmable read-only memory, the data can be erased by applying electric field. In EEPROM it is used volatile light, and here we are using electrical field. No need of ultraviolet light. Ultraviolet light we are not requiring the ultraviolet light. We will using electric field only. We can erase only portion of the chip only. Difference between ROM and RAM. RAM is volatile, it is not volatile. Data in RAM is permanently written when power is off, data is deleted. It is written permanently on hard disk. In ROM, permanently not erased. Data in RAM is not permanently written. When power is off, data is deleted. Where in ROM, the data is permanently erased. It is not permanently erased. In ROM, it is permanently erased. RAM is of two types, dynamic and static. ROM is of three types, ROM, PROM and EEPROM, and one is EEPROM. Then RAM, it requires flow of electricity to retain data. And in case of ROM, it is not necessary. It can retain data without electricity also. It does not require electricity for retaining the data. RAM is the memory available for the operating system program and processes to use when the computer is running, means it is directly in contact with the CPU. ROM is the memory that comes with our computer, that is pre-written by the manufacturer, and it is used at the time of booting the system. Initially, output devices, we can see the output devices, different output devices on which we are giving the output after processing. They are speaker, monitor, headphone, printer, plotter and all. Next, the comparison between the compiler and interpreter. What is compiler basically? A compiler is a program that converts the high level language into machine language and ready for the compiler to run it and give the output. Whereas interpreter does the same work, but the interpreter do step by step, one instruction at a time. Difference we can see it. Input, it takes an entire program whereas this take a single instruction at a time. Output, it generates an intermediate object code. The interpreter never generates an intermediate code. Working mechanism, the compilation is done before execution. Compilation in interpreter, the compilation is done at the time of execution. The speed in compiler is faster, in interpreter it is slower. The memory requirement for the compiler is more, and the memory requirement for the interpreter is less. Whereas errors displayed, all errors after compilation at the same time, where the errors line by line are shown one at a time. Error detection is difficult in case of compiler, it is easier in the case of interpreter. Then pertaining programming languages, C, C++, these are all using compiler, whereas Python, Java and all are interpreted language also. And on the other hand side, we can see what is assembler. Assembler is a type of computer program that interprets the software program written in assembly language. Likewise, like compilers and interpreter, the assembler is used to interpret the program that is written in assembly language into machine language that is ready to be executed by the program. An assembler enables software and application developer to assess, operate and manage a computer hardware architecture and component that is more nearer to the hardware. An assembler is sometimes referred to the compiler of assembly languages. It also provides the service of an interpreter also. So we will be studying these three in comparison: compiler, interpreter and assembler for assembly language. Next is the languages. The machine language, that is the language that is more nearer to the machine, that is in form of 0, 1 and 0, 1. Whereas the high level language, that is entirely an English type of language, and the low level language is again an English type language statement. We can see the comparison between high and low level language, that high level language are easy to learn, whereas the low level languages are difficult to learn. High level languages are near to human language, whereas low level languages are not far from the human language but nearer to the machine. Translator is required in high level language. No translators are required in low level languages. Program in high level languages are slower, but the programs in low level languages are faster. Middle level language, third type of language. There are machine language, high level, low level and middle level language. That is third type of language. Middle level language is one of the language which is closer to machine, computer as well as to human also. A language that has a feature of both low level as well as high level language, that is defined as a middle level language. More formally, a high level language that allows you to write a low level program, and it is called a middle level language. For example, C. Okay. And then next we will be discussing the direct access and sequential access of the data from the hard disk or from the memory. It is of accessing the data. It is of two types: directly and indirectly. Directly we can see random also, or sequential, that is step by step process, that is given in the figure also. Means we can see that the sequential access is slower and the random access or the direct access is faster than the sequential access. Then rest is the exercise in which we can find out the questions and the solution, the presentation, as well in the worksheet or the solution sheet that I have provided and the notes I have provided. Rest you can see the online links. We can go to the online links and practice more and more programs and give certification exam also. And rest for any of the query you can revert back to me. Then rest it's fine. Have a nice day. Thank you.